Hi, welcome to the video on how much calcium-41 was in the marble. So we have already gone through and identified our given information in our find, and then we use that to figure out which equations, which of these two half-life equations we're going to use first, which one we're going to use second. So remember, you look at the find, and since we're looking for the initial amount, that means that we're going to use the equation with the initial amount in it. So equation B last. Our find tells us what we use last. So we're going to use equation A first, and then we'll use equation B. And I actually like it when we use equation A first because I don't have to use logs when I use equation A first. So yay. All right, so let's go ahead and plug in our information to equation A. So equation A says number of half-life cycles equals elapsed time divided by half-life. And we're always going to use whatever equation we're using first, we're going to use it to find the number of half-life cycles. So I'm going to plug in my elapsed time, 690,000 years, and divide that by my half-life, my 99,400 years. All right. So my number of half-life cycles, which again just counts the number of half-lives that occurred in the amount in the elapsed time. It's not the same as the half-life, it's just counting how many half-lives have passed. So 690,000 is my elapsed time divided by 99,400 as my half-life. And then when I plug that into my handy dandy calc, I get 6.94 as my number of half-life cycles. Okay, so now that I have that, the next thing I'm going to do is use equation B second, and I'm going to plug in the number of half-life cycles into equation B. I plug in my final amount, my 14.5 grams here, and then I solve for my initial amount. So starting with my final amount, the 14.5 grams go into there. So I got 14.5. I'm sorry, that's milligrams, not just grams. And I'm going to cross out the units for now because I don't need them until the end. I find the units to be distracting when I do my math, so I just leave them out. And half-life cycles, by the way, they don't have units, it's just a count. Okay, so the initial amount is what I'm looking for, so I'm just going to leave I as for my unknown variable. And 2 raised to the power of the number of half-life cycles is 6.94. Okay, so the math I'm doing here is when you have a fraction next to an equal sign, you can use cross multiplication. So I'm going to use that. To help me solve here. So I would get 14.5 times 2 raised to the power of 6.94. Now it's important to know that, and that's equal to my initial amount. It's important to know that these are not like terms, so you're going to have to use your PEMDAS rule. So you can take 2 raised to the power of 6.94 first and do that. And what I meant by these are not like terms, it's not like you can distribute the 14.5 to the 2 first and then raise it to everything to the power 6.94. You have to do this separately because these two are not like terms. So we get 122.78, and then we're going to multiply that value by 14.5. Okay, and I get this number here. So that means my initial amount let me just check my sig figs here. I only have 2 sig figs. So first I'm going to, from this value here, first I'm going to write everything out so we can see. And since we're dealing with amounts, we're going to use the units that we had for our final amount, milligrams. That will be the same units we have here. Initial amount will be in milligrams. But to get this in correct sig figs, since I have only 2 sig figs here, all right, that's 18,000 milligrams. Now if you wrote this as your final answer for right now, that's fine because we haven't gone fully through sig figs, but I just want to get you guys used to seeing these problems rounded or these answers rounded in sig figs. All right, that is it for this video. So that one's pretty easy. Have a quality day.